So as I was saying, as I had said in the over the group that the agenda for today is going to be relation and functions. A lot of people have their school exams coming up, and relation and functions is inevitably in the syllabus of every uh, school, kind of. And we don't have much to discuss. The Howrah batch is running one class behind, so we don't have we need to cover, I need to cover that lecture up so that then we can have a common Zoom session for series and progressions. So I thought let's make up for the time and discuss something that would be very relevant to you people in the immediate future, right? So we are going to discuss about relations and functions. Obviously, not in too much details, but only up till the extent that is needed for your school exams, so that you are able to solve questions pertaining to them and understand solved examples related to them from the books, school books. Just solving school books for now would be enough. You don't need to worry about anything else for relation and functions as of now. We will discuss this particular topic once again in complete details when we go to class 12 at the beginning of calculus. The session right now is just purely for the sake of school exams, so that you people can be a little bit more comfortable and bit more confident about your school exams that are starting soon, half yearlies that are starting soon. Okay. So with that, let's start with this discussion on this chapter, relation and functions. So the first thing that we need to understand for relation and functions is what is an ordered pair? An ordered pair. Okay. If we have two numbers, paired in a way where the of the number order of the numbers is fixed, then it is known as an ordered pair. Now, when we say that the order of the numbers is fixed, the order implies that we know that which number will appear first place, and which number will appear in the second place. Okay. Number in the first place and number in the second place, this is fixed. Right? Typically, an ordered pair is represented in this way: A comma B with first brackets. Okay. This is what we refer to as an ordered pair. So for an ordered pair like this, A is the number in the first place, B is the number in the second place. Okay. And it will always be such. A very common example of ordered pairs is like in the Cartesian system. If we have the Cartesian system and we take any point in the Cartesian system to be represented in the form of x comma y, okay, this is one of the simplest and the best example of ordered pairs. The coordinates of any point, the coordinates of any point are an ordered pair. They are an ordered pair. Okay, this is the simplest example to understand. Like for example, if I take a point 1 comma 2, so 1 comma 2 will specifically represent a point over here. Similarly, if we have a minus 3, 3 comma minus 4, so it will specifically represent a point in the fourth quadrant. Okay, then like suppose we have a minus 2 comma minus 4, there will be a point in the third quadrant. So all of these unique pairings, okay, are known as ordered pairs. Okay. An ordered pair is always a unique pairing, a unique pairing of numbers. Yeah. So generally, what we refer to as an ordered pair in the sense is like, now relation and functions are very closely related to set theory, and it has a lot of things that is common between sets. So suppose if we have a set A and we have a set B. A has elements like A, B, C. B has elements like 1, 2, 3. And from the two sets, we want to create ordered pairs. Okay. So there are two ways in which you can create an ordered pair from this. You can either create an ordered pair in the sense x comma y, where x belongs to set A and y belongs to set B. So this would imply that the first position will be represented by the elements of set A and the second position will be represented by the elements of set B. So ordered pairs that are created in this form would be like A comma 1, B comma 2, C comma 3. Okay. We can have A comma 2, A comma 3, and so on and so forth. And another way of creating the ordered pairs would be like we can have it in the form of y comma x, where again x belongs to A and y belongs to B. But now in this case, what happens would be this would imply that the first position of the ordered pair will come from elements of set B, and the second number of the ordered pair will come from the elements of set A, which means the ordered pairs that would be created in this case would be like 1 comma A, 2 comma B, 3 comma C, and so on and so forth. That is how we create an ordered pair. Okay. An ordered pairs requires a pairing of two numbers. And then we have to define that, okay, where will the first number come from? Where will the second number come from? And then we have it as an ordered pair. Is everyone clear with this? Yeah.
Yes, sir.
So in that case, please note down a very important property that we have for an ordered pair, which is like an ordered pair in the form of AB is not the same as the ordered pair BA in general. Right? This would be like saying if we have a point 1 comma 2 and a point 2 comma 1, do they represent the same point on the Cartesian system? Nope. You know, not the same point. Hence, A comma B is not the same as B comma A. But in case if it is given, but in case if we are given something like this, that an ordered pair A comma B is indeed equal to X comma Y, an ordered pair in the form X comma Y. When will this happen? What will this imply?
A belongs to X and B equals to B belongs
It
to
would
Y.
imply that A is equal to X and B is equal to Y. Okay. If two ordered pairs are equal, then the respective elements must be equal. Like for example, suppose if we have a question like this, x plus 2 comma y is equal to, yeah, ऐसे कर लेते हैं एक बार. X plus 2 comma 1 is equal to 5 comma y minus 3. Find x and y. It's a very basic simple question. So since it is given that the two ordered pairs are equal, so what must happen?
X plus 2 should be equal to 5.
X plus 2 must be equal to 5 and 1 must be equal to y minus 3. So what do we get for x? So x is 3, y is 4. Is everyone okay with this?
Yes, sir. Yes, sir.
Okay. So after ordered pairs, then we come to the next definition, which is the Cartesian product. Cartesian product of two sets. Now, the Cartesian product of two sets is defined as the set of all possible pairs that can be created from the elements of the two sets. Which is like if we again take up the example, the previous example, where we have a set A containing A, B, C, and we have a set B containing 1 and 2 for the moment. Okay. Then A cross B, this is how we represent the Cartesian product. A cross B, that is the representation of the Cartesian product. And A cross B implies that we are trying to create all possible pairs in the form of A comma B, where A will come from the elements of set A and B will come from the elements of set B. And all such pairs that we can create will be present in the set. Okay. Even the Cartesian product is a set. Okay. It is like a set. It is also a collection of entities. What entities? Pairs. Okay. So A cross B will be, what are all possible pairs that we can have for A? So A comma 1, A comma 2, B comma 1, B comma 2, B comma, then we'll have C. So C comma 1, C comma 2. These are all possible pairs that we can have between A and B. A can pair with these two, B can pair with these two, C can also pair with these two. So these are all the pairs that we will get. Okay. So this is referred to as the Cartesian product. And just as we have defined the Cartesian product for A cross B, we can also have a Cartesian product of B cross A. Now, what would happen in the Cartesian product of B cross A? In the Cartesian product of B cross A would imply that the first element comes from set B and the second element will come from set A. So the pairings that we get in this case would be like 1 comma A, 1 comma B, 1 comma C. And then we'll have a 2 comma A, 2 comma B, 2 comma C. You know? Now, again, a few points to note about the Cartesian product. First one, much like how the pairing works, A cross B is not the same as B cross A. Because if you look at the sets, the entities present in the sets are different because the ordered pairs are different. Clear? Okay. Next important relation or point that you have to remember is if the number of elements in A is P and the number of elements in set B is Q, then what would be the number of elements in the Cartesian product?
P into Q.
P into Q.
The number of elements in the Cartesian product would be P into Q, which would actually also be the same as the number of elements in the Cartesian product of B cross A. Okay. The two Cartesian products A cross B and B cross A will not be the same, but they will contain the same number of elements. Okay. If you look at this, the number of elements in A cross B is 6. The number of elements in B cross A is also 6. Okay. So their number of elements in the two will be the same, but they will not be the same individually. Okay. Next, third, if A cross B is a null set, then what will this imply? This would imply that either A is a null set or B is a null set or both A and B are a null set. Well, at least one of them has to be a null set. Okay? Because cross product, the Cartesian product is not defined over a null set. There is nothing to pair with. For a couple of intersection union relations, which is like A cross B intersection C is the same as A cross B intersection A cross C. And similarly, we have a relation for the union as well. B union C is A cross B union A cross C.
Sir, this is distributive law.
Yes, distributive law for Cartesian product. Okay. Cartesian product also follows the distributive law. Clear everyone on this? So that's the brief introduction on Cartesian product. And then we come to one of the main agendas that we have. Relations. So what is a relation? A relation is any mathematical rule that helps in pairing the elements of set A with the elements of set B is known as a relation. Okay, is known as a relation. Any mathematical rule that helps in pairing the elements of set A with the elements of set B is known as a relation. ठीक है ना? Which is to say, suppose we have an set A and we have a set B. Now, set A has few elements in the form of 1, 2, 3, and set B has a few elements in the sense of 2, 4, 6. Okay. Now, a relation between A and B, a relation from A to B is represented in this form. Pehle to hoga ARB. That is the representation of a relation. This implies that we are defining the relation from A to B. So in the ordered pair, the elements of set A will appear first. Elements of set B will appear in the second place. Okay, ARB. So ARB, generally, a relation is defined in this way. That ARB, we are trying to create ordered pairs in the form of A comma B, where A comes from set A, B will come from set B, and then we define the mathematical rule such that, let's suppose twice of A is greater than B. So ये हो गया the relation, the mathematical rule. Okay. The mathematical rule is twice of A has to be greater than B. So now, in accordance with this rule, what pairings can we create over here?
1,4, 1,6.
2A is greater than B.
2, and 3, 4.
तो 1 को अगर यहाँ पे डालेंगे तो क्या आएगा? 2 आएगा. बट 2 कैनॉट बी ग्रेटर देन एनी एलिमेंट्स ऑफ बी. बी का सारे एलिमेंट तो उससे बड़ा है, तो 1 विल नॉट पेयर विद एनीथिंग. फिर 2 देखेंगे, 2 का डबल होगा 4. 4 कैन पेयर विद 2. सो पहला पेयर आएगा 2,2. is anyone able to understand this?
Yes, sir.
ठीक है. फिर अगला a का वैल्यू आएगा 3. तो 3 का ट्वाइस हो गया 6, which means 3 will pair with 2 and 3 will also pair with 4. 3 and 4 will be a pair that will satisfy this relation. So this is referred to as the outcome of the relation. This is the outcome of R. That a relation defined from A to B, where twice of A is greater than B, will yield the following pairs. Okay. So any mathematical rule that can establish connections between elements of set A and elements of set B is known as a relation. Is everyone okay with this?
Yes, sir.
You know. Now again, note for this. First part. Any relation will always be a subset of the Cartesian product. Okay. Which means that any relation that we write, A or B, will always belong to A cross B. Well, it's very simple to understand in the sense that what does A cross B imply? A cross B is like all possible pairs. This is all possible pairs. And A or B will be selected pairs. Excuse me. Will be a few selected pairs. So whatever pairs we select, they will always belong to all possible pairs. So any relation will always be a subset of the Cartesian product. ARB is always a subset of A cross B. Next. So in that case, we could also say that any subset of the Cartesian product becomes a relation. Alternatively, we can also say that any subset of the Cartesian product, कोई भी एक random subset बना दिया Cartesian product का, that will also represent a relation. ठीक है? Now, the second definition actually helps us in calculations of mathematical values in the sense that now, if the number of elements in A is P and the number of elements in B is Q, then we already know the number of elements in A cross B will be PQ. Okay. In that case, what would be the number of relations that can be defined from set A to set B? What happened to the number of relations that can be defined from A to B?
Will be equal
So
to
we go
PQ.
back to the property that any subset of the Cartesian product is a relation. Now, if the number of elements in the Cartesian product is PQ, how many subsets can we create of it? Two to the power PQ, 2 to the power n hota hai number of subsets. We did this in set theory. So the number of relations that we can define from A to B is 2 to the power PQ. Okay, isn't clear with this? So a question. If the number of elements in A is 3 and the number of elements in B is 4, find the number of relations from A to B. क्या होगा आंसर? ओरल क्वेश्चन.
2 to the power 12.
This would be 2 to the power 12. Okay. Moving on. Next. Domain, range, and codomain of a relation. Next topic, domain, range, and codomain of a relation. Okay. So let's again, let's say we have a scenario like this. We are given an example that we are defining a relation from natural numbers to natural numbers such that, yeah, छोड़ो, let's write it in the proper form so that you're not एक ही format use करते हैं. Let's be consistent with that. So suppose we have a relation which is defined as it will have values of the form a comma b, where a belongs to the set of natural numbers, b belongs to the set of natural numbers, such that a plus 2b is equal to 13. Okay. Now, find the outcome of this relation. Find the outcome of the relation. So what will be the numbers that will have in A? If A is 1, B would be 6. So 1 comma 6 आएगा. If A is 2, 11 by 2 हो जाएगा, not a natural number. So 3 comma 5. Then we'll have 5 comma 4. Then we'll have 7 comma 3, 9 comma 2, and 11 comma 1. देखो, this would be the outcome of R. Is everyone comfortable with this?
Yes.
So,
ठीक है ना? Now, domain of R. So domain of R is defined as the set of all elements in the first place that are present in the pairs belonging to the outcome. The set of all elements present in the first place that are set of elements in the first place that are present in the pairs belonging to the outcome. So, जैसे in this outcome, what are the elements present in the first place? 1, 3, 5, 7, 9, 11. So the domain of this relation will be the set of numbers 1, 3, 5, 7, 9, 11. Is everyone able to understand this? Clear?
yes, sir.
Alternatively, the domain of the relation is also defined as the set of input values participating in pairing. Okay, the set of input values that are participating in pairing. Okay. Now, what we mean by the second definition is, for this question, what is set A? Set A originally is defined as all natural numbers. So we'll have 1, 2, 3, 4, 5, 6, 7, all the natural numbers in this. But are all natural numbers participating in pairing?
No, sir.
No. The only numbers that are participating in pairing are 1, 3, 5, 7, 9 and 11. So the set of those input values that participate in pairing are known as the domain. Okay, na? And the same thing will happen for B as well. B initially is defined as the set of natural numbers. So even this will have 1, 2, 3, 4, 5, 6, 7 going up till all natural numbers included. But again, are all natural numbers participating in pairing for B? Nope. You know. So then write down a note that the values of set A creating pairs are known as pre-images. Okay, are known as pre-images. They say 1, 3, 5, 7, 9, 11. These elements that are participating in pairing are known as pre-images. Okay. And the complete set of pre-images is what is referred to as the domain. Okay. Although we call them as input values, but the technical term for input values is pre-images. Okay. The reason why we call them as input values is because when later on when we discuss functions, it will be very easy to understand functions in terms of input and output. And that is how we always consider functions, input and output. Okay. Okay. Next, so that was the domain. Now, range of R. So the range of R is defined as, okay, if you look at the first definition, it will be the set of all elements present in the second place of the pairs belonging to the outcome of R. Okay. So if you look at the example again, what are the elements present in the second place? 6, 5, 4, 3, 2, 1. So the range of this relation will end up becoming the set of values 1, 2, 3, 4, 5, 6. Okay. I hope all of you remember in a set, order of values doesn't matter. Okay. It's not an ordered pairs. It's a simple set. And in a simple set, the order doesn't matter. So whether you write it as 1, 2, 3, 4, 5, 6, you write it as 6, 5, 4, 3, 2, 1, it is all the same. Makes no difference to that. Is everyone okay with the definition of range?
Sir, can you explain the range again?
Range would be the set of all elements present in the second place of the ordered pairs. Of the ordered pairs belonging to the outcome of R. Okay. So यहाँ पे what are the elements in the second place? 6, 5, 4, 3, 2, 1. ये second place पे है हर ordered pair के. So the complete set of the elements present in the second place is what is defined as range.
Okay, sir.
ठीक है ना? Alternatively, range is also defined as the set of all output values participating in pairing. ठीक है, like in set B, 1 2 3 4, set B is the set of natural numbers, but सारा तो pairing पे काम कर नहीं रहा है. The pairs that are created will include 1 2 3 4 5 6, खाली ये pairs बनाएंगे. Right? And then note the values of set B that participate in pairing are known as images. Okay, they are known as images. And then last में होगा codomain. So codomain is defined as the complete set B. Complete set B is the codomain, irrespective of whether the values are participating in pairing or not. Okay. Irrespective of the values participating in pairing or not. Doesn't matter. It is the complete set B. Is everyone able to understand the definition of domain, range, and codomain? So let's try to solve a few set of examples that we have in order to have a better understanding of this. So suppose a question is a relation ARB is supposed to contain the pairs 1, 2, 2, 3, 4, 5, and 6, 8. So in that case, find the domain and range of R. Total question है, what will be the domain and range of R?
The domain would be 1 2 4 6.
Yes, correct. The domain of this relation would be 1, 2, 4, 6, because these are the elements present in the first place. And what would be the range of the function?
2 3 5 8.
2, 3, 5, 8. This would be the range of the relation. ठीक है ना? अच्छा. Sometimes questions may be asked in this way as well. What is the image of 2 in the relation? What is the image of 2 in the relation?
3.
1.
नहीं,
3, 3.
3. Image क्या होता है? Image is the second element. ठीक है, तो 2 को फर्स्ट प्लेस पे रख के ये चेक करना होगा उसकी सेकंड प्लेस पे कौन सा एलिमेंट है. दैट वुड बी द इमेज. 1 कब आंसर होगा? अगर क्वेश्चन ऐसे पूछा होगा, फाइंड द प्री इमेज ऑफ 2. फाइंड द प्री इमेज ऑफ 2 in R. तो इसका आंसर क्या होगा?
1.
इसका आंसर होगा 1. ठीक है, बिकॉज अगर प्री इमेज निकालना है तो दैट इंप्लाइज 2 इज प्रेजेंट इन द सेकंड प्लेस एंड वी हैव टू फाइंड द फर्स्ट प्लेस. ये 2 अब सेकंड प्लेस पे है, उसका करस्पॉन्डिंग फर्स्ट प्लेस निकालना है. ठीक है ना? दैट इज हाउ वी डिफाइन इमेज एंड प्री इमेज. Okay, next question. Suppose we have a set A which is defined as -1, 0, 1, 2, 3, 4. And we have a set B which is defined as 1, 2, 4, 6, 9. Okay. Now we are defining a relation which will pair elements of in the form of A comma B, where A comes from set A, B comes from set B, such that A square is equal to B. Okay. Ajak. Now the question, first question. Find the outcome of R. First question, find the outcome of R.
Sir, 1,1.
Sir, -1, 1, 2, 4, 3, 9.
Yes, sir.
So A square is equal to B. The pairs that we have in this would be -1, 1, 1, 1, and then 2 will pair with 4,
2, 4, 3,
3 will
9.
pair with 9. ठीक है ना? And that will be it. So this would be the outcome of R. Now in that case, what would be the domain of the relation?
-1, 1, 2.
-1, 1, 2, 3.
-1, 1, 2, 3. Perfect. Okay, what would be the range of R?
1, 1,
1, 4, 9.
अरे 1, 1
4,9.
क्यों होगा? It's a set. You cannot have identical elements. 1, 4, 9. That is it. 1, 1 क्यों होगा? Set है. Set में you cannot have identical elements. So no matter how many times 1 comes in the outcome, range में एक ही बार आएगा. Clear?
Yes, sir.
Okay. And what would be the codomain of the relation?
1, 2, 4, 6, 9.
1, 2, 4, 6, 9.
Codomain would be the entire set B. उसको फर्क नहीं पड़ रहा कि भाई they are whether they are participating in pairings or not. Codomain is entire set B.
सर एक बार थोड़ा सा ऊपर कर दूंगा.
एक बार जरा सा.
सर तो रेंज कोडोमेन का सबसेट हो गया क्या?
Range will always be a subdomain of subset of codomain. That's a good point that you raise. ठीक है, यहाँ पे you can actually add a note that the range of any relation will always be a subset of its codomain. Range is always a subset of the codomain. ठीक है ना? Okay. Next question. A relation is defined as A comma B, where A belongs to natural numbers, B belongs to natural numbers, such that A plus B is divisible by 5 and A and B are less than 10. A and B are less than 10. A and B are natural numbers such that A plus B is divisible by 5 and A and B are less than 10. Find the outcome of the relation. So what do we have in this?
3,2.
So let's say we list them out. इनके लिए क्या क्या possible values है? 1, 2, 3, 4, 5, 6, 7, 8, 9. Because it has to be less than 10. Okay, B के लिए क्या क्या values होगा? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now look at all the possible pairs that we can have divisible by 5. So 1, 4. Pair 1, 9. Okay. 1 के लिए 2 पेयर्स बनेगा, 1 4 and 1 9. ओके, 2 के लिए
2 3 and 2 8.
2 3.
सर उधर लेस देन 10 है ना?
A and B, हाँ तो A and B have to be less than 10. तो अभी तो 9 तक ही ले रहे हैं.
नहीं सर, लिखा क्वेश्चन में।
A and B individually are less than 10. ठीक है, फिर आ जाएगा 2 8. Then we'll have a 3 2, 3 7. Then 4 के लिए we'll have 4 1, 4 6. फिर 5 के लिए there'll be 5.
5.
6 के लिए we'll have a 4 and we'll have a 9. 7 के लिए we'll have a 3 and a 8. 8 के लिए we'll have a 2 and a 7. And for 9 के लिए होगा 1 and 6. देखो, is everyone okay with this? So this would be the outcome of R. Now, in this case then, what is the domain of R? 1 2 3 4 सब कुछ आ जाएगा up till 9, क्योंकि सारे एलिमेंट्स हैं फर्स्ट प्लेस पे. What be the range of R? ये भी पूरा हो जाएगा 1 2 3 4 up till 9. Clear? Okay. So that was the basics of relations. Now we go into the basics of functions. So what is a function? So function is defined as, pehla definition of a function is like it's a special case of relations where every pre-image pairs with one and only one image. Yeah. It's a special case of relation where every pre-image pairs with one and only one image. Like for example, suppose we have a set A consists of A, B, C, and we have a set B. It consists of 1, 2, 3. Now, in order for a relation defined from A to B to be a function, function ko we denote by small f. Okay. For a relation to upgrade into a function, the condition is every element, there are two restrictions applied. The first restriction is every element of set A must create pairs And the second condition is every element of set A must have only one pair. Okay. दो condition satisfy करना होगा. So which is to say that in the current setup, if we want a function to be defined from A to B, then it would imply that every element in A, which is like A, B, C, must create a pair with the elements in B and only one pair with elements with B. ठीक है ना? So something of this form, suppose A, 1, B, 2, C, 3. This is how a function should look like. Where every element of set A is creating a pair and only one pair. This is a function. ठीक है ना? So the first kind of question that you get on the basis of relations and functions is you will be given an outcome of a relation and you would have to identify whether it is a function or not. Okay. Like for example, suppose we have a relation defined from A to B which contains element pairs like A, 1, B, 1, C, 2. Is this a relation or not? Oh, sorry, is this a function or not?
सर
हाँ.
सर ये ए टू बी वाला फंक्शन में A, 2 एंड B, 1 ऐसे लिख सकते हैं क्या?
हाँ.
ओके.
अच्छा ये बोलो, is this a relation or not? मतलब is this a function or not?
Yes, sir.
Yes, sir.
It is a valid function because every element of A is creating a pair and only one pair. ठीक है ना? Also note the restriction is only applied on the elements of set A. Set B पे कोई restriction नहीं है. ठीक है? This is a function. अच्छा. Suppose we have something like this. ARB is defined as A, 1, A, 2, B, 2, C, 3. Is this a relation or a function? But is this a valid function?
No, sir.
This is not a function. Why is this not a function? Because A के लिए we have two pairs. A is creating two pairs. ठीक है? Function नहीं होगा. C. If a relation is defined as A, 2, B, 3, is this a function?
No, sir.
Even this is not a relation function. Why? Because C is missing. C का पेयर नहीं है इसमें. Clear? Next, domain of a function. So domain of the function is the complete set of input values for which the output of the function remains real and finite. ये condition होता है domain के लिए, ठीक है? That it is the complete set of out values for which the output of a function remains real and finite. जैसे basic domain conditions. जैसे अगर if we have y is equal to log of fx, या just जनरल में ऐसे ही लिख लो, अगर एक log function है तो what is the condition for the domain? The
Input cannot be negative.
entity inside must be greater than 0. If we have a root, then the condition is entity inside must be greater than equal to 0. If we have a rational function, okay, fx by qx या px by qx, then इसके लिए condition क्या होगा? qx must not be equal to 0. These are basic domain conditions जो लगता है जिसपे questions आएगा in your school exams, right? Then you would be having questions, find the domain of. अब एक क्वेश्चन ऐसे दे देगा मे बी y इज इक्वल टू log ऑफ 4 माइनस 3x. तो log के लिए डोमेन का कंडीशन क्या होता है? एंटिटी इनसाइड मस्ट बी पॉजिटिव. सो वी डायरेक्टली राइट 4 माइनस 3x मस्ट बी ग्रेटर देन 0 और 4 इज ग्रेटर देन 3x which would imply x is less than 4/3. तो ये डोमेन हो गया इसका. x will belong to minus infinity to 4/3. ठीक है. Similarly, if we have to find the domain of something like this, root over of x square minus 3, तो इसका डोमेन का रेस्ट्रिक्शन क्या होगा? x square minus 3 must be greater than equal to 0, which would imply x plus 3 into x minus 3. क्वाड्रेटिक इनइक्वालिटी है, बेबी कब से सॉल्व करो, must be greater than equal to 0. माइनस इन्फिनिटी इन्फिनिटी रूट्स आ गया -3 and 3, सॉरी रूट होगा ना, तो -√3 to √3. पॉजिटिव नेगेटिव पॉजिटिव, अपने को क्या चाहिए? पॉजिटिव चाहिए. So the answer for this will end up becoming x belongs to minus infinity to minus √3 union √3 to infinity. Yeah. Sometimes we might have a question like this. Find the domain of y equals to x square plus 1 divided by x square minus x minus 2. So इसके लिए we'll apply the condition that the denominator must not be 0. So x square minus x minus 2 equal to 0 solve करो. तो ये क्या देगा? x minus 2 into x plus 1 is equal to 0. तो इसका रूट्स आ जाएगा x equal to -1 and 2, which means for -1 and 2 the denominator will become 0. So the domain of this function would be all real numbers other than -1 and 2, because -1 and 2 के लिए denominator 0 हो जाएगा, which is not possible. Okay. बस ऐसे ही अभी के लिए तो क्लास 11 में तो ऐसा बेसिक क्वेश्चंस ही रहेगा डोमेन को लेके। इसका डोमेन निकालना होगा। सो विल डू इट इन द सेम वे, x प्लस 1/2 माइनस एक्स इज ग्रेटर देन 0। फिर वे भी कर्व कर लिया, माइनस इन्फिनिटी टू इन्फिनिटी। एक रूट है -1, एक रूट है 2। फिर यहाँ पे 3 डालेंगे तो ऊपर वाला पॉजिटिव है, नीचे वाला नेगेटिव है, तो नेगेटिव पॉजिटिव नेगेटिव। therefore this implies that x has to lie between -1 and 2। ये इसका डोमेन हो गया। ठीक है ना? Is everyone clear with this? So that would be the basics of relation and functions that you would be needing for your school exams. One part of functions, which is how to find the range of various type of functions, is something that we are not discussing right now because वो काफी बड़ा topic है, and then there are a lot of things that we have to understand about it as well. A part of range, like range of trigonometric functions में we did, so that will also be included in this. Finding range में ही वो भी आएगा. And then in the next chapter that we go quadratic में, उसमें we'll learn how to find the range of the polynomial expressions and stuff like that. So I don't want to club that part right now. So otherwise क्या होगा कि it will become a mess when we discuss it later. So I don't want to put anything thoughts in your mind right now. We'll just discuss it with the chapter, with the the way that we have it organized in the chapter. So this is what you need to know for
Sir,
relations and functions
explain the
basics.
concept of,
Hello? हाँ शगुन
sir,
बोल।
can you explain the concept of R inverse and all that?
R inverse. Okay, inverse of a relation. Inverse of a relation 12 में नहीं है क्या? I thought 12 में होगा. Inverse of a relation which is represented as r to the power -1, R inverse, is basically defined as, acha, for any relation defined from A to B, its inverse is a relation defined from B to A that will reverse the order of the pairs present in R. That will reverse the order of the pairs present in R. ये फंडा होता है R inverse का. जैसे if we have a relation defined from A to B and it has pairs in the form of 1,2, 2,4, 4,6, 3,9, something like this. Then what would be then this? Its inverse, R inverse, will effectively be a relation defined from B to A. ऐसे लिखेंगे इसको, B R inverse A, and the outcome of this would be the same pairs that we have in R but written in the reverse order. जैसे 1,2 का 2,1 हो जाएगा, 2,4 का 4,2 हो जाएगा, 4,6 will become 6,4, 3 comma 9 will become 9 comma 3. This is inverse. ठीक है, तो R में क्या होता है? A is the first element, B is the second element. If R has pairs like A comma B, where A belongs to set A, B belongs to set B, then R inverse will have the same pairs in the form of B comma A belongs to A and B belongs to B. खाली जो ऑर्डर है वो रिवर्स हो जाएगा, वो चेंज हो जाएगा. And that is how we define the reverse, our inverse.
So what's the application of
Yeah.
इसका application क्या है?
So a couple of properties that we get for this is domain of R will become the range of R inverse, and the range of R will become the domain of R inverse. You know? Any other questions?
सर आप सिग्नम एंड जीआईएफ एंड ऑल नहीं कराएंगे?
नहीं, not now. Signum, GIF, mod, ये सब we will discuss in class 12. ठीक है? Because we need to discuss them in details, and just abhi ke, if I give you a couple of examples of that, it will only confuse you people more without actually serving any purpose. So greatest integer function, box function, modulus function, signum function, fractional part function, all of these will be discussed in class 12 when we do relations and functions in the proper sense. ठीक है ना?
ठीक है
The
सर.
class that I have taken today is just a very, you could say that it's just a basic introductory class which will help you get through your school exams. Nothing more. Okay, it is just for your school exams, reference to your school exams. Okay. Okay then. So I'll see you all in the classes. Bye everyone. Good night. Take care.
सर नेक्स्ट ऑफलाइन क्लास में भी हम लोग रिलेशंस एंड फंक्शंस ही करेंगे या
नहीं,
सीक्वेंस एंड
ऑफलाइन
सीरीज?
क्लासेस में विल डू सीक्वेंस एंड सीरीज जो चल रहा है. You can
Okay,
treat
sir.
this as an extra class. Okay, it's just an extra class that I've taken for school exams. Bus. Otherwise, this class has no other significance. Okay. Okay. So then, good.